Hello, my name is Paul Thomas Edward Cusick. I'm an engineer by education, but I do a lot of medical research. I was invited to submit a talk to to this conference on nursing education, and I thought I'd just speak today in a brief talk about how I use engineering education to apply to solve medical problems. And I think it's something that all the nurses could benefit from in education. So nurses have more access to patients even than the doctors do. This makes observations by knowing the patient's history and condition. They have an excellent opportunity as a nurse or nurse practitioner to do and publish research. I know I was in the hospital myself. I used to speak to the nurses every night. They come in to see you, and you get a lot more time with them than the doctor. The doctor has more demands on their time. They don't have the time for each patient as the nurse does. So we use engineering methods, and when I'm writing my papers, it basically follows given, determined, solution, answer format. So this amazingly effective technique for research in the medical science is what I call the engineering method of research. It relies on engineering mathematics. Uh, engineers use problem. Engineers are problem solvers. They often work from first principles from science. The method involves the following program. So you have you're given certain set of data, determine a cure, determine a treatment, uh, solution, what the actual final analysis is, and your answer. Given, determine, solution, answer. That's how engineering reports are written. So the given involves data, the determine involves the research questions to be solved, the solution usually involves a sketch in terms of the given data, and what is being asked. The answer is usually a number. That can be a statement based on the determined question. This engineering technique is very powerful for addressing and is used in countless times in engineering. So I suggest that a section in the engineering method should be added as analysis and cure. A section should be added to it in a scientific medical paper. It should include a section called analysis, cause, and cure. Medicine must continue to go beyond diagnosis only. We seem to pride ourselves too much on the diagnosis, but not on an actual treatment. They say doctors don't heal; they treat. So anyway, the emphasis on the long words that they use for describing diseases and things—that's not what's important. What's important is getting to a treatment that brings about a cure. So from first principles, engineers work from first principles of science. In fact, the degree I have is called a Bachelor of Science in Engineering. It's different from a Bachelor of Engineering. They also call it a Bachelor of Applied Science instead of engineering. And what it does is it's more science based than just a Bachelor of Engineering is. Bachelor of Engineering is more practical with the hands-on duties of an engineer, whereas the science is more research based. So if you're looking for engineering courses that are helpful to the medical sciences research and education of nurses, look for ones that are in the applied sciences or in a Bachelor of Science in Engineering. So there's four basic equations that I discovered in astrotheology mathematics, AT math I call it, and I'll just run through them quickly here just so you've seen them. But there's really the first one is the golden mean parabola. That's where you have a function parabola which is x squared minus x minus 1 equals 0. It's a parabola that opens upward. And if you use x as the value time, then time squared minus time minus 1 is equal to energy. And That has roots of the golden mean, 1.618, and the other root is minus 0.618. That's the formula for energy. Then we have the formula for mass, which is simply equal to the ln of the time, ln t. It's the ln function. And we have time is equal to kinetic energy, which we all know from elementary high school physics, 1/2 mv squared, where m is the mass and v is the speed, sometimes the speed of light squared, which is 300,000 kilometers a second squared. So that's so we have energy, mass, time, and the final formula is space. It's called the vector cross product from linear algebra, and it is the magnitude of the energy vector times the energy of the time vector times the sine of theta. And when it becomes really significant is when the time and the energy, the space and the time are equal, rather. And so we end up with energy is equal to 1 over sine theta. Sine theta is 60 degrees, sine of 60 degrees is 0.866. So the energy is 1 over 0.866, which is about 1.15. So the next important thing in astrotheology mathematics, I'm just running through quickly here for you, is the function equals its derivative. So if you have a function and it's equal to a derivative, so we just showed the function to be t squared minus t minus 1 equals e. So if we take the derivative of t squared minus t minus 1, we just have 2t minus 1. So 2t minus 1, and we set them equal because the function equals the derivative. So the derivative, 2t minus 1, equal to the function t squared minus t minus 1. You can solve it for t. There's only one variable there. So you solve for t, and t happens to be equal to 3, which is the speed of light. If you plug that 3 back into the equation, either one of those equations, 2t minus 1, so it'd be 2 times 3 minus 1 is equal to 5. 2 times 3 is 6, minus 1 is 5. So the energy is equal to 5. So when time is 5 and then when time is 3 and energy is 5, we have that the function is equal to the derivative. And that's when everything happens, because velocity and acceleration, which are proportional to force and momentum, are determined by the velocity and the acceleration. And velocity and acceleration, acceleration is the derivative of velocity. And actually velocity is the derivative of position. So we have s for position is equal to ds by dt, or velocity, v, is equal to d2s by dt2, which is equal to acceleration. So the function equals the derivative is the main thing you should get out of that. So you have a function, and as it's plotted, it spirals in on itself, and the function is e to the power t, because the derivative of e to the t is e to the t, and the derivative of the second derivative of e to the t is e to the t. So it never changes. It's always the same. That's critical. So the derivative of sine, the sine function, from trigonometry, the derivative of sine is equal to cosine, and the derivative of cosine is equal to minus sine. So if we set those equal to the derivative of the function, we have sine t equals cos t, and they're the same as 45 degrees. I don't know if you remember the 45-degree triangle, the 1, 1, root 2 triangle. The legs of the triangle are 1 and 1, and the hypotenuse is root 2. So the sine of the 45 degrees is equal to 1 over root 2, the opposite over the hypotenuse. That's equal to 1 over root 2. That's equal to 707, which is very important in astrotheology. So that's just a quick run through astrotheology mathematics, but that's very useful in medical research. So arguing that it is too difficult is not a valid excuse if you want to do medical research. The technique in the future of medical research is engineering math, AT math. And the engineering report style, which the author has developed in other papers, is a necessity for push forward with advances in medical research. Not that we haven't done pretty well so far, but we can do better. So there are programs and journals in biomedical engineering. Universities should move towards these programs. While it is true that the various branches of engineering cover mainly a particular branch of science, civil engineering study mechanics, mechanical engineers study dynamics, electrical engineers study electricity and magnetism, chemical engineers study chemistry. They're all just different branches of physics. But I happen to study them all because I bounced around and between electrical, mechanical, and civil, and settled on civil. But I got the basic courses in electrical and mechanical as well, which gave me more math, which was a blessing. God works wonders. I think that applied science will be more prevalent as it covers ground in the various branches. That's the future, applied science. They have it at Queen's in Kingston, Ontario. Even with one course in each branch can suffice for multidisciplinary engineering medical research. So you don't have to be an expert electrical engineer to analyze a simple circuit, and you don't have to be an expert civil engineer to analyze a simply supported beam. These things can be done pretty easily, and if someone's interested, the first 2 years of engineering is engineering diploma, and be very useful for people who want to be doctors in medical education. Uh, but for nurses, we'll get to that a little later on. Slides. We're nearing completion here. Told you it was a short talk. So recommendations, the mathematics solutions I developed is called AT Math. All the background that is necessary to understand it is elementary calculus. You've seen the function equals derivative. Elementary differential equations. I didn't show you the Clairaut equation, but it's the second derivative is equal to the function. Elementary linear algebra. You saw that in the space function. Space is equal to energy cross time. And which would be covered in a first-year university math course for nurses. So you'd have the calculus, the differential equations, the elementary linear algebra, all covered in one math course for nurses. And some people actually get it in high school. I know they teach calculus in high school now. They didn't when I was there, but they do now. And if you can teach someone in grade 3 to do long division, then you can teach someone who's 20 years old how to do calculus. Because calculus isn't that difficult. And certainly not at the level that's needed for this medical research. So you need trigonometry, which you've seen sine and cosine, and algebra. You've seen that with the golden mean parabola. All that can be gotten in a high school. All this can be gotten in a high school is not that complicated. A single course in Physics 1000, in other words, a one-year course in physics should be mandatory for nurses. They probably take, I know they take organic chemistry. I took it myself. And they would take physical chemistry as well as physics. And I think the nurses are capable of it, and I think they should take it, and it will help do more medical research. Maybe not every nurse needs it, but the more they have it, the better. The more research they can do, and as I said, they have more access to the patients than do doctors, and they can build a repertoire with different diseases that they see in their particular floor or their ward. So anyway, that's all I have to say. This is the I'm reading. Here's my name, address, and email address. So thank you very much for listening, and I hope you've enjoyed the talk. And I know a lot about engineering, but it's they're starting to blend together with nursing. So anyway, I hope you've enjoyed the talk. Thank you very much.